Hello, my name is Desiree Leapart, and I am a graduate student at George Mason University enrolled in HAP 823, Comparative Effectiveness, taught by Dr. Alemi and Dr. Woodeman. I will be presenting on multi-level regression modeling and will walk through an example using R. With multi-level regression, we are able to model individual relationships, group relationships, and examine the link between the two levels of variables. Multi-level regression involves creating two sets of regression models for individual and group-level variables to see what factors impact a particular outcome while controlling for patient mix. Why separate? Including both variables or both levels of variables in one model may distort the relationship. For example, when group variables are correlated with individual level characteristics, individual characteristics may distort relationships among group-level variables. In terms of hospitals, they differ in the patients they care for, and a multi-level analysis is usually more accurate because it removes these differences. Here's the question that we'll walk through for the remainder of the presentation. The following simulated data, which I'll show in the next slide, show the survival of patients in 2 tertiary medical centers and 3 community hospitals. Predict patient survival rates using patient-level variables. Identify the intercept for each hospital. Regress unexplained variation in survival probability on features of the hospital, and report the meaning of these 2 related regressions. Individual patient factors are the individual level variables, while the hospital features are the group-level variables. Here's the data that we'll use for the problem. Probability of survival is our outcome or dependent variable, while severe burn, head injury, 65 years of age and older, male, and hospital type are our independent variables. Now I'll walk through the solution of the problem using R. The first step is to read the data into R by first determining your current working directory and then routing R accordingly to where the data is saved and reading the data into R. If you did not delete the first blank column in the data that we were provided, then you would use the following code, which removes that blank column. The next step is to run the first regression using the patient level, which are the individual level variables, using the R code here. As you can see, all variables except for being male were statistically significant predictors of probability of survival, all having a negative impact on probability of patient survival. For step 3, we create the table that describes the hospital characteristics using the following R code. The first column of the table displays the hospital if the hospital has a tertiary center, with 1 being yes and 0 being no. The second column displays if the hospital has a burn center, again with 1 being yes and 0 being no. And the third column shows the difference between the y-intercept we got from running the first regression on the independent or on the individual level variables and the coefficient for each hospital, hospital A, B, C, and D. Note that the patient characteristics are removed or left out or ignored, removing the effects associated with patient characteristics. The next step will be to run the second regression, which includes the group level data after controlling for patient characteristics. As we can see, both types of hospitals, hospitals with a tertiary center and hospitals with a burn center, have a statistically significant impact on the probability of patient survival. Hospitals with tertiary centers reduce the probability of survival or have a negative impact on the probability of survival, while hospitals with burn centers increase the probability of survival. In conclusion, all patient factors except for being male were statistically significant predictors of survival, having a negative impact on patient survival, and both types of hospitals have a statistically significant impact on the probability of patient survival. Hospitals with tertiary centers actually reduce the probability of survival, while hospitals with burn centers increase the probability of survival. Here are my references, and thank you for watching this presentation.